right, welcome, folks. We're just giving it a few more seconds for everyone to come in through the waiting room. So just give us about 30 seconds and we'll get started. All right, it looks like the waiting room is pretty much cleared out now, so we're going to go ahead and kick off. I'd like to welcome everyone to this Linux Foundation Energy webinar, Introduction to EVerest. We are privileged today to have two of the maintainers of the EVerest project here to present this webinar. So thank you both to Kai and Pete for joining us. I just want to note this is being recorded, and afterwards we will be sending out a link to both the video recording and the slides. Additionally, if you have any questions at all throughout the webinar, just use that Q&A button in the bottom of the Zoom interface. You can go ahead and type your question at any point. We are not going to get to the Q&A until the end of the presentation, but we will go through those questions in the order that they were received when we get to the end. And we will try and endeavor to get through as many of the questions as we can in the time available. So with that, I'd like to thank everyone for joining us, and we'll pass it over to Pete to introduce our speakers.
All right. Hi, everyone. We are excited to present the EVerest project to you today. I will be hosting together with my colleague Kai-Uwe Hermann, who's a senior architect at Pionix. My name is Pete Gömpel. I'm the team lead of the open source development team at Pionix that is mainly responsible for all the open source contributions that we do around the EVerest project. This is the agenda that we prepared for today. We will start with a very high-level overview about what EVerest is, and then we will dive into the technical architecture of the project, talk about the repository setup, protocol support, and the hardware drivers that the project provides. And then we will also talk about the EVerest community and who that is, and point to documentation about the project and how you can get started. And afterwards, as Dan mentioned, we will have the Q&A session. So what is EVerest? EVerest is an open source software stack for EV chargers. So it's software that actually runs on charging stations. The project is community driven. It's developed on the Linux Foundation Energy, and it's Apache 2.0 licensed, which is a very industry-friendly license. Basically allows you to freely use, modify, and distribute the software, even in commercial applications, as long as you include a copy of the license and provide proper attribution. EVerest runs on an embedded Linux device. It's designed in a way to support many different hardware platforms. So it runs on AC chargers and DC chargers with different kind of hardware setups, one EVSE, two EVSEs. So the modular framework allows for that different configuration. And it is designed to standardize and accelerate the EV charging infrastructure development. So I'm trying to go to the next slide now, but it doesn't seem to work. Maybe I just need to wait a little. There we go. Talking about EVerest features and functional blocks. So EVerest is basically a rich collection of modules for all the domains that are relevant for EV chargers. That includes, on a very high level, core charging logic, protocol support for protocols like OCPP and ISO 15118, hardware driver implementations for power meters, for RFID readers. It provides features with respect to energy management and load balancing, authorization, and also tools to simulate your charging station on the development machine together with EVs that are also simulated. Why do we actually need EVerest? So what you can see here is a diagram with different kinds of standards and protocols that have evolved over time, grouped into different domains like DCA, C Cloud Grid, and other. And there are just so many requirements that charging station manufacturers really have a hard time catching up and having a hard time to fulfill these requirements. You can see things like OCPP 1.6, 2.0, ISO 15118 here. And this is where EVerest becomes really valuable. With EVerest, we want to provide a shared base layer for all the kinds of standards and protocols that exist within EV charging. In order to support charging station manufacturers, in order to use that stack for what we think is mostly commodity software, so that manufacturers can focus on other parts of the charger, and things that every charging station needs to implement is provided by EVerest. EVerest is already used in the field a lot. You can see a list of EVerest-based chargers on the left side and EVerest-based dev kits and controller boards on the right side. We're currently estimating that it is used within 30,000 production chargers in operation. And just in 2025, we have been scaling from 10,000 to what we expect will be 400,000 by the end of the year. And now I will head over to Kai, who will dive into the technical architecture.
Yeah, thank you very much. Basically, the architecture of EVerest is kind of like a very modular architecture where we have modules that communicate with each other via MQTT, make use of certain libraries, and their lifecycle is basically managed by what we call the EVerest Framework Manager. And you can kind of see that some of these modules can be grouped into modules that are related to EV communication, OCPP communication, modules more in between, and I will tell you more about this on an upcoming slide. But first, on the next slide, you can see what we mean with modular architecture. So the so-called EVerest framework enables this flexible microservices architecture. These modules I just showed are basically individual Linux processes that expose multiple interfaces to each other via MQTT. There is a configuration file that makes sure that all of these modules are properly connected and that you can't connect things together that are not supposed to be connected. We have the framework that allows us to start and stop these modules from a central place. All of the communication happens via MQTT, but it is completely transparent to the modules. So the modules don't really know that they talk to each other via MQTT. For most of the modules which are implemented in C++, it's just a function call that then transparently gets translated into a MQTT call. And this also allows us to have quite the loose coupling. We only have these interfaces. So module A just calls out a command on another module, for example, and you can have multiple implementations or multiple different implementations of these modules. And the framework itself manages this RPC, like I already mentioned, also argument type safety, and also the checking of dependencies in between. And you can see here in the bottom is two sample or example modules, module A and module B, where module A provides a fictional charger interface that has one command that is able to set the maximum current with an integer parameter, and is also able to provide a variable, also an integer variable, this energy charged variable here. And module B can then just require this charger interface and is then able to call commands on module A, as well as receive asynchronous variables or events via MQTT as well. So, and on the next slide, you can see how you can basically configure a charging station with these kinds of modules. This is like a simplified example of how the module setup can look like for a charger. So on the left side, you can see the vehicle that's represented by this nice little EV icon. This is connected via the typical CP connection to some hardware that is interacting with some form of driver, which we typically call the EVSE board support. This is a driver that is able to read the CP states and interact with the hardware, like opening relays and things like that, for example. Additionally, if you're running a bit more complicated setup, not just basic charging, but let's say AC charging over ISO 15818 or DC charging, we will also have a Slack module as well as an ISO 15118, in this case, the -20 module connected to this. This is all getting orchestrated by what we call the EVSE manager. This is a very central module in all charger configurations because it contains the core charging logic, the state machine, basically for how charging should happen. And on top, you can see this EVSE security module. This is an abstraction we have for mainly for handling all kinds of certificates. Yeah, and on the right, multiple other modules connected as well. And yeah, if you go on to the next slide, we can probably mostly skip this one because I already mentioned all of the things. But the next slide, yeah, this one. This is the site where you would configure, let's say, an OCPP 2.0, 2.01 or 2.1 module that is able to connect to an OCPP backend. This module is typically also connected to an EVSE manager, but also makes use of this EVSE security abstraction I already mentioned, because also OCPP has quite a lot of certificate management that is needed to be done. And it's also connected to an authentication module. And in this example, it is hooked up to two RFID readers that can provide so-called tokens that can then be consumed within the authentication system. And yeah, you end up with a functioning charger that is also OCPP implemented. Then next slide, please. And the upcoming slide as well. So now we're going to talk to you a little bit about the repository setup. So EVerest is, let's say, split up over multiple different repositories, where the core collection of all the modules that I just mentioned and all the interface definitions and type definitions and things like that are collected in the EVerest core repository. There you have these modules that contain the implementation of the charging logic, but also the interface with various libraries. And these modules, of course, make use of the EVerest framework I already talked about earlier, which is also in another repository. And this makes sure that the module communication, the structure of how the modules need to be written, the schemas for configuration checking and things like that, that they are implemented in this EVerest framework. We then have also multiple different libraries that the modules make use of. For OCPP, we have developed a library that we creatively called libOCPP. And this has implementations for OCPP 1.6, 2.0.1, and 2.1 in it, and is then deeply integrated in these OCPP modules I already mentioned. For ISO 15118-20, we have the lib ISO 15118. It's also making use of this lib CPV2G, the lib Slack for the Slack communication process. And as I already mentioned, the certificate management mainly runs with this libev security and the associated module. Then I will give back to Pete.
Yes, and we will have a look at the protocol support and the hardware drivers that are provided by the EVerest project next. And we will start with OCPP 1.6 support in EVerest. All feature profiles of OCPP 1.6 are implemented as part of libOCPP, the library, but also in the OCPP module. So if you're using EVerest, you get full OCPP 1.6 support, including the feature profiles core, firmware management, local auth, list management, reservation, smart charging, and remote trigger. And there's also support for the OCA white papers for extended security features, ISO 15118 plug and charge, and also California pricing. And currently, the OCPP 1.6 stack is undergoing the OCA certification process. For OCPP 201, it looks kind of similar. All functional blocks are implemented. You can see a list of those below. We are missing some use cases in the smart charging section, namely K11 to K17, which are mostly related to ISO 15118 based smart charging, which is not used by any EV in production, which is why we skip that for now. And we are also aware of some limitations of the advanced monitoring, namely the active monitoring base. But also the OCPP 201 stack is already basically certified, used within certified OCA products for the certification blocks core, advanced security, smart charging, and local auth list management. EVerest also supports OCPP 2.1 already, which was only released a couple of months ago. So everything that is supported in OCPP 2.0.1 is also supported in OCPP 2.1, which is mostly backwards compatible. So you could also say EVerest supports OCPP 2.1 core. But of course, the specification also provides new functional blocks and extends existing functional blocks. So that is what we're currently working on, focusing on the extension of the functional block smart charging with use cases that have been added there, and also use cases that have new functional requirements. Then we have started to implement the new functional block for bidirectional power transfer that is very much related to everything that comes with ISO 15118-20. And we're focusing also on the DER control. And on the roadmap, we have the extension of the functional block authorization, and then depending on how the market will develop and based on basically needs of the community, we will also look into battery swapping, what is a new functional block in OCPP 2.1. On the ISO 15118 side, we have support in EVerest for ISO 15118-2. I've listed the supported blocks here: AC/DC, TCP and TLS 1.2 plug and charge, certificate installation, and the pause resume feature. We're currently working on making the internet service available and also on certificate update, although certificate update is also something that is not used in production by any or most of the EVs. And then as to-dos for the -2, we have schedule renegotiation and smart charging, which is also based on market and community requirements, since that is also not really used in production, and therefore we have not prioritized this so far. For the ISO 15118-20, we also have support in EVerest for the supported blocks listed above. TLS 1.3 is new. We have started with DC and DC-BPT support, MCS, external payment scheduled mode, dynamic mode, and mobility needs mode, and also implemented the pause resume feature. Currently, we're focusing on the implementation of AC and AC-BPT, And there are some pull requests already open to add support for this. We will work on plug and charge, certificate installation, schedule renegotiation, smart charging, and also the internet service. And then below, I listed other blocks that we will prioritize based on community and market requirements as well. Worth mentioning some other ISO 15118 related implementations. So of course, we also support DIN spec 7121, which was a predecessor of the ISO 15118-2. Kai already mentioned the CB V2G, the XE generator, and Slack. There's also support for the SAE J2847-2. And on the roadmap is to implement the VW bidirectional extensions. Zooming in a little bit on the energy management support in EVerest, there's one central module in EVerest that is responsible for that. That's called the Energy Manager. It has a very flexible architecture that allows to represent basically arbitrary physical and logical energy components as a complex tree structure. So you can really design your grid connection fuses and fuses of your charging stations and define where you want to have external inputs. It supports load balancing between multiple EVSEs. If your configuration, your charging station has multiple EVSEs, it can do that. It's fully integrated with OCPP 1.6 and OCPP 2.x smart charging. So that just works out of the box. It supports one-phase and three-phase switching and provides an MQTT API to integrate it with other energy management systems as well. We are currently focusing on the integration of the bidirectional charging. It has support for it already, but as probably many of you know, OCPP 2.1 and also -20 comes with a lot of additional requirements with respect to the energy management and discharging of EVs. So we're extending that. The colleagues from ChargeByte are currently working on yet another energy management API in JSON RPC in order to provide more information about the charging station and to control basically the power of the charger. And there are already PRs to integrate OpenADR and EEBus as other energy management solutions. And on the roadmap, we have Matter, at which we also want to have a look at. The hardware driver support. You can see a list of devices and products where open source drivers are available. You can see a list of power meters, power supplies, board support packages, RFID readers, and payment terminals. Those are all available open source. There are many more from different commercial vendors that are closed source sometimes, but we are working together with the component suppliers to add new drivers also to the open source repositories. And there's even more on the roadmap. Just recently, we got a code donation for GPT and CharleG. So that's the implementation of these protocols, which still needs to be integrated within EVerest. And we're about to get started with that, as well as support for CharDemo, where we are talking to the CharDemo organization and discuss a private donation. And as soon as there's enough community pull, we will start to integrate this as well. If you're missing something, of course, you can reach out and let us know. All right, I'll give back to Kai, who will talk about the community.
Exactly. So speaking of community, who are the people who are in the EVerest community? We picked out a few as shout outs, more or less. So you can see it's quite a long list of organizations that have contributed in some way to the code that is in EVerest. Some really notable mentions here are Alphen and also Compleo, who work on the OCPP, especially the OCPP 2.01 integration, as well as the 2.1 integration in the past and also in the future. We have the Joint Office of Energy and Transportation, US government organization that also joined the EVerest Technical Steering Committee a while back and has contributed quite significantly to the OCPP stack as well. ChargeByte has already been mentioned by Pete. They have mostly done work on ISO 15118 and XE, but also, as already mentioned, currently working on this energy management JSON RPC API. We have Quello, who are also on the technical steering committee and have donated or worked on the Rust support in EVerest and basically most, if not all, of the Rust modules that are in EVerest core at the moment. And of course, Pete and I, we both work for Pionics. We have contributed quite a bit to the EVerest project, and some shout outs that I really wanted to do is like Analog Devices have created a piece of hardware that is a AC board support hardware, basically. And they've also contributed a driver for that, as well as Isabellenhütte, who contributed a driver for a power meter in the recent months. So in total, we estimate that around 50 organizations with maybe around 500 engineers have contributed code in some way to the EVerest project, and we expect this number will only grow in the future. So next slide, please. I already mentioned the technical steering committee. This is a official monthly Linux Foundation Energy meeting of the project. This oversees the project's development, can guide the development direction, take votes if there are ever things that are maybe a bit controversial or need additional guidance. But this meeting is also used to present the ongoing work in different areas of EVerest development, which we organize in working groups, and I will talk about this in a minute. But we also present just the current state of the project, what goes into our monthly source code releases, and talk about interesting things that happened in the last month in the EVerest community and events we attended. It's always on the fourth Thursday of the month at 5 p.m. Central European Summertime, 3 p.m. UTC, and the recordings are available on YouTube to consume afterwards. There's also a live stream of it happening, as well as the slides are shared on our mailing list. And with that, next slide, please. I mentioned the working groups. So in EVerest, we organize the working on specific topics in so-called working groups. At the moment, there are 4 of them that meet regularly. We have the car communication group that meets every 2 weeks on Wednesday and is mainly concerned with things like ISO 15118-20 at the moment and related topics, of course. The cloud communication group also meets Wednesdays every 2 weeks and focuses mostly on OCPP 2.01 and 2.1 development at the time. Then we have an energy management working group on Mondays every 2 weeks, where we can discuss things like the OpenADR integration, eBus integration, and things like that that are currently ongoing. There's a megawatt charging system, the MCS working group, that happens once a month on Thursdays. And we have a weekly welcome call on Tuesdays, which is meant for people who are interested in the project, want to learn a little bit more, maybe want some guidance where and how they can contribute, or just want to basically have a quick chat about the project and how they can use it, how they can contribute, things like that. You can find the agenda of all of these working groups in the provided link here. And then we also have some additional communication channels. Our main communication channel is the Zulip chat, which is basically an open source version of Slack. So you can sign up there and find a lot of chat groups there with a lot of questions that people have asked and discussions about various topics related to EVerest and EV charging. We, of course, still have a mailing list but most of the communication, I would say, nowadays is on Zulip, just because of the chat-like nature. There's a wiki in the LFE Confluence, and for issue reporting, most of the repositories, or basically all of the repositories in the EVerest org, have all kinds of different templates to report issues, basically where they where you stumble upon them. And then I will give back to Pete again.
Yep. So here we have listed 3 sources of documentation around the EVerest project. So the first one is the EVerest main documentation entry point, where you can find explanation tutorials around the project, sections how to get started. And it also contains the reference documentation, which has a separate link below, which contains documentation about all the modules that exist in EVerest, all the interfaces, all the types, which is partly auto-generated documentation, like based on the types and interfaces, which is very useful, but there's also lots of custom handwritten documentation around all the modules that is very valuable. And then for lib OCPP, we actually have the hosted Doxygen documentation on the link that is shown below. We would like to finish off with some hardware to get you started. So there's the Belay box, which is a development kit from Pionex. It's an AC charging station that runs EVerest, and also the hardware is open source. So the Yeti, the low-level board with the CP communication, the lower level part, and the YAC, which is the high-level board that actually runs the Linux and EVerest. There's a link to the reference hardware and to the shop. And we also wanted to list the device that Kai already mentioned that was developed by Analog Devices that you can basically use to replace the Yeti. And Phytech also has the Phytech cubes for AC and DC. Those are based on the production controller from Phytech, the PhyVerso. So you can use the EVCS Cube Basic for AC and the EVCS Cube POC for DC, and you can find those on evcs-cube.com. And that leads us to the Q&A session.
Yes, and we have quite a few questions that have come in, so we'll take them from the top. The first was, how does EVerest-based subsystems perform on fast-acting interfaces like safety, for example, overcurrent or leakage, and how fast can they act?
So usually, maybe I can take that one, Kai. So the safety-related implementations for EV charging stations usually run on the lower level microcontroller part. So usually you have a split of a lower level microcontroller that is then connected to EVerest that runs on the Linux system. And usually all the safety implementations are actually implemented on the microcontroller, since this can be safety certified and you don't want to safety certify a Linux that you regularly update. This is how this is usually implemented within EV chargers.
Great. Next, I believe this was already answered during the presentation, but this person may have missed it. Do you have any implementations done?
I mean, I can take this. So the answer is yes. Most of all the things we talked about today have implementations. It's just some parts that are still very active in development, like parts of ISO 15118-20. But you can certainly build a charger based on EVerest today, and like Pete already mentioned earlier, I think, what was it, 40,000 chargers that we estimate are running with EVerest. And this is chargers like AC home chargers, but also DC fast chargers. So the whole spectrum of available hardware, so to speak.
Perfect. Next question. Which algorithms are supported in Energy Manager load balancing?
Right. Maybe I can go back to the slide to explain a little bit about this. There we go. So you can set up your energy management basically as a tree structure. So a relevant the module that actually contains the algorithm is the energy manager, but it makes use of what we call energy nodes. So those are separate modules, and these modules define either like static metadata like fuse limits, but you can also define external limits. This is indicated by these arrows that you can see here for example, API or OCPP. So what the energy manager does with respect to load balancing is that it distributes the available power across multiple EVSEs. So just a very simple example, if we have like 22 kilowatts available in total for 2 EVSEs, and we have EVs connected to both charging stations, those will be distributed evenly across the 2 chargers that will then consume 11 kilowatts. We have the phase switching support switching between 1-phase and 3-phase, which means if the power drops below, the available power drops below a certain limit, maybe because of an OCPP limit, for example, below 4 kilowatts, you cannot provide that on 3 phases anymore because you need 6 amps on every phase. So if you activate this in your energy manager, and the charging station, of course, the phase switching, of course, which is a requirement, then you can switch between 1 phase and 3 phase. We plan to implement other features of the energy management in the future. As you can see here below, the current development focus is to make like integrate OCPP 2.1 with lots of requirements. And all the requirements that come with ISO 15118-20. By the way, the requirements from OCPP 1.6 and 2.x, like 201 or 2.1, they are implemented as part of libOCPP and the OCPP module. So there are also algorithms involved with respect to how you should merge profiles that you receive from the central system, so from the backend. And this is all done in the OCPP stack. So there's just a composite schedule that is provided to the EVerest Energy Manager that's then used and applied. What we plan to do with respect to load balancing is to actually track also the consumption of every single EVSE in order to distribute the available energy more efficiently. So let's say we split 11 kilowatts between the 2 EVSEs. In the example that I talked about, if there's just a single EVSE that only consumes 6 kilowatts, we have 5 additional kilowatts available that we can then distribute to other charging points. So this is something that we want to extend and that we will start working on soon. I hope this answers the question.
Seem pretty detailed. So you might want to stay on this slide actually for the next question. One potential feature for future residential EVSEs would be support for the Matter protocol, which I see you have on the roadmap here, in order to enable integration of the EVSE into Matter fabrics and applications. Does EVerest have any plans to support Matter? Specific Matter API clusters of interest are the device energy management mode, and energy EVSE mode.
Yeah. So you can see that we have it on the roadmap. I'm not too familiar with the Matter standard, so I cannot answer the details of the question, but we hear it from different sides that this can and is going to be interesting in the future. So we will definitely have a look at this soon. And of course, if anyone's interested in contributing to that, yeah, feel free to reach out and get in touch. I would expect that the foundation for it is kind of ready. As you can see, we have an MQTT API already that allows energy management systems to control the power. ChargeByte is working on the JSON APC energy management API that provides additional information. And I would assume, without knowing Matter in detail, that the functionality that we need to provide on the backend side is kind of similar.
Awesome. And the next one I think is related. Are the EVerest MQTT interfaces documented? And if so, where can I find them?
So
yeah.
basically, there's, I think, two parts to this question, two parts to the answer. So one of them is the internal interfaces. While they use MQTT for the modules, it doesn't really matter that they use MQTT, but these interfaces, they are documented on the in the main documentation. If you go in the EVerest reference, for example, there you find a list of all the modules and all the interfaces and types that they use, and that's where you can find documentation on that. If you want to have a look at the outward-facing MQTT API, this is done via the API module, and this uses a really simple MQTT API that you can, for example, bridge towards something like home energy management systems or home automation systems like Home Assistant, for example, and interact with EVerest over that. And this is meant to be consumed from the outside world. So there's a bit of documentation on the things here. And I expect when the JSON RPC energy management API is also available, this will probably also include some of the additional API functionality that we have available via MQTT at the moment in another protocol as well. Hope this answers the question.
Great. The next one's very specific. Can you let me know who from Arizona State University is involved so I can connect with them?
I'm not sure, Kai, but I don't know who is involved, but maybe we can just discuss this via Zulip. I think they were fuzzing around with OCPP a little bit, testing that interface. But Kai, maybe you know more.
No, unfortunately, I'm not sure. I would have to look it up, but then I guess we can come back to you.
So that might
just
be a
reach
better
out on
question
Zulip
through
and then we can discuss it. Yeah,
the Zulip chat. Okay, great. Next, which ISO 15118 chips and modules are supported by the lib ISO 15118 currently?
I'm aware of the QC8000 from Qualcomm and the Lumicil PLC chip. And Kai, I think there's one more that we have tested.
If I would only remember from the top of my head, but yeah, you probably have to look it up in the documentation.
Yeah, I also don't know from the top of my head, but I'm quite sure there's a third one. Maybe we can also provide that after the presentation.
Okay. Yeah, if it's in the documentation, that's a good answer too.
I think it's Vertex.com.
Yeah, Vertex.com. That's the one.
Perfect. The next question I'm going to paraphrase because it's kind of long, but this comes from someone who has some background in building mobile apps for EV chargers, finding EV chargers, and some EV fleet management, open source projects, and they're wondering if there are any internships or apprenticeships available related that would be relevant for someone wanting to transition into building software for EV chargers. Or do you know of any resources where they could find that type of apprenticeship or internship?
I'm not aware of any specific positions for that, but I know in Zulab we have a channel where, like in general, it's worth it to reach out on Zulab. Of course, we have the issue tracking activated and throughout our repositories, also where where we're mentioning where help is wanted and very welcome. And in Zulab there is, I think, also a channel around like jobs and openings, but I'm not sure if that was just something that we thought about or something that has already been published. Not sure, Kai, if you know more about this.
Not really, but I mean, it's certainly worth a try to reach out to basically all kinds of organizations that are involved in EVerest, and there might be an open position available.
Great. Next is a multi-part question. What OTA update mechanism does EVerest use for its embedded Linux-based controllers? Start with that one.
I think I can take this one. So EVerest itself doesn't give you any restrictions on what to use. Like we have successfully used Rauk in some deployments, but you could use anything basically that does updates. For, let's say, if you build a Linux system that EVerest runs on and you use Yocto, you're in luck because we have a meta layer published that keeps track of the most recent releases typically for Yocto, Kirkstone, and ScarfGap. So you can just wrap this in any over-the-air update mechanism that you want. And you can then adapt basically the scripts that we have in the system module, for example, to trigger software updates via OCPP, for example. But you have complete freedom in this regard.
Perfect. Their next question was about safety, but we covered that on a previous question. The next one is, does EVerest support integration with energy metering ICs, such as the ATM90E32AS for power and energy monitoring?
I think not for this specific module, but we have all the basically interfaces that are, let's say, needed to write a driver for something like this. So yeah, if you have hardware that you would like to see basically EVerest support, you can see how you can interface with it, write a a small driver, and don't shy away from opening a pull request, and we're typically quite open for contributions.
Yeah, and maybe picking up the question before that, because I think it goes a little bit into another direction. So functional safety requirements such as isolation monitoring. There's an isolation monitoring interface in EVerest, so which is connected to the EVSE manager module, which controls basically the isolation management, but you can write a driver to actually control your isolation monitoring device. I think there is no open source implementation of any isolation monitoring driver in the open source EVerest. I need to check, but I think this is the case. Things like ground fault detection is usually done by the module implementing the board support interface, controlling relays, ground faults, and other kinds of safety. That is usually part of what the microcontroller is doing, and then like this, these signals are communicated to the higher level EVerest software running on the Linux, reacting to that, reporting this error, stops the session, charging accordingly. So that's how it is integrated with EVerest.
Great. Next, are there any comprehensive training programs or onboarding resources to help development teams understand and work with the EVerest source code?
Well, there are quite some resources online, for example, available on the Linux Foundation Energy YouTube channel. There are the documentation resources that we have here, listed here. Of course, there is quite an active community that is very happy to help out via Zulip. Yeah, of course, it helps to join the working groups, ask your questions. So we do these working groups, to give an update on what we are currently working on, discussing with contributors, but we also use them if new people are interested in certain domains or have questions to answer questions there. So yeah, there are quite some resources and channels that you can use to get started.
Fantastic. Next, for someone building a DC system, what starter kit would you recommend?
We have listed, give me a second. Yeah, hardware to get you started. So that will probably be the Phytec DC Cube, which uses the Phytec 5 Verso controller and comes with a DC power supply and EVerest with it. So that's probably a good hardware to get started with.
Beautiful. Next question, in register_signal_set_charging_profiles_callback, how can we access the raw charging profile data, stack level, limit, duration, etc., before it's processed into composite schedules?
The libOCPP API does not contain any call to actually get the raw profiles, because the whole idea is that libOCPP does the whole processing for the composite schedules and just provides the composite schedule that is then applied. I could think about an extension of providing the raw profiles as well. Of course, they are stored in the database. Yeah, that you could theoretically access, but I would rather think about making the raw profiles available. But we did not have the use case yet that other applications were actually interested in that. For OCPP 2.0.1, it might be a little bit different because there's an actual OCPP message to get the raw profiles installed on the charger. So it also makes sense to make that publicly available to consumers of the library. And of course, if it makes sense for 2.0.1, it also makes a little bit of sense for 1.6. So currently, there's no such function in the API, but I could think that we can extend it.
Okay. And related, how does libOCPP internally process remote start transaction when authorized remote TX requests is set to true? Specifically, what's the authorization flow? Does it first call the authorization callback, then check local authorization list, and finally send authorized to CSMS?
So authorized remote TX requests is a configuration parameter in OCPP to specify if remote starts should be authorized by the CSMS. If this is set to true, I mean, it's a very specific question, but the libOCPP just calls the provided token callback that publishes this token, and the libOCPP consumer is responsible for checking the argument of the provided token callback and check if it's pre-validated or not, because in case authorized remote start transaction request is set to false, we don't need to authorize this token, it's validated already. But it should, the libOCPP consumer should then use the authorize or validate token function to actually validate the token using the CSMS, and that will then take care of using the authorization list or the authorization cache. I would like to highlight if you use OCPP with an EVerest call and not only the library, all that is done for you automatically.
Okay. And for any, very technical questions like that, I would certainly point folks to the mailing list or to the Zulip chat. Next, how about support for ISO 15118-8 Wi-Fi and ISO 15118-20 ACD? I think we've talked about 20 already, but
yeah, we talked about 20. And I know of contributors that also work on the -8, but I'm not aware of the current state, but I know people are working on it.
Yeah, there's been some discussion. The ACD part, that's the pantograph charging. There has been some discussions on Zulip basically, because I think it's mostly related infrastructure. So basically Linux setup for certain Wi-Fi modes and things like that, that you need to have this. So because this basically is an alternative to the on-wire communication or the Slack communication basically. So if there is interest from you, please check on Zulip and feel free to revive some of the threads. Maybe some of the people have just shelved this for other more interesting topics for them, or they actually continue working on it and are just not in a sharing mood at the moment. So please.
Great. And I'll just flag as well that when we send the video and the slides out, the same email will include links to the Zulip, the mailing list, the website, the documentation, GitHub, etc. Just so don't worry, anyone on the call, that you won't be able to find that because it'll all be sent directly to your inbox in the next 24 hours. We're almost at time, but we can try to sneak one last question in, which is, do you have any thoughts on a sunspec module for DER, BESS plus EVSE?
Definitely makes sense to add something like it, and definitely possible to add it. Yeah, there is some kind of sunspec support already in EVerest. I think there's a lib sunspec that also that already implements some like.
It's more of a scaffolding, and I think the related modules we have actually deprecated or even removed because there hasn't really been that much interest in it in the past, and it didn't make sense to keep around something that was basically only barely functioning. But if there is interest in it, please, reach out, and maybe this can be brought up to speed again.
All right, perfect. Well, we are at time, so for those couple questions that we weren't able to get to, what we'll do is we can move those into Zulip so that folks can answer those offline. And I'm happy to post a copy of all of the questions that were received there. So with that, I'd like to thank both of our presenters as well as all of our attendees for joining us today. Again, we will be sending the recording and the slides and all of the links to various resources out to everyone who did register for this webinar. So keep an eye out for that. And with that, thank you all again and have a wonderful day.
Thanks. Bye-bye.
Thank you very much for attending. Bye-bye.